Okay, so yesterday you looked at ways to solve linear systems through substitution, meaning one of the equations in the linear system said y equals. And so you plugged that in for y in the second equation because the second equation read something like 2y plus 5x equals 21. So you used the distributive property and you solved the linear system that way. And then once you found that variable, you plugged it into one of the equations to find the second variable. So today, we're going to look at things a little bit differently. We're going to solve by elimination. And this means that we're going to get rid of either the x value, or I'm sorry, the x variable or the y variable in order to fully solve this system. So I want to introduce this by going through our first example. So what we see here is we have a 6x minus 5y equals 21. And then in the second equation, we have 2x plus 5y equals negative 5. So I want you to notice two things. One, in the first equation, you have a negative 5y. In the second equation, you have a positive 5y. Meaning that if we put these two equations together as an addition problem, we can get rid of or eliminate y because negative 5 plus 5 is 0, meaning we would eliminate that y. So I'm going to show you this instead of trying to explain it in words because I think it will make more sense if I go through the problem for you. So we have the equation 6x minus 5y. And I'm going to add to that the second equation here. So I'm going to add to this equation plus 2x plus 5y, and I'm going to set that equal to 21, which was the solution, or which was what we set our first equation equal to, plus negative 5, which is what we set our second equation equal to. And so we're going to combine like terms and solve this problem. Now, I want you to notice something. I could rearrange, but I'm not going to. What I notice here, firstly, is that I have a negative 5y and a positive 5y. And if I add a negative 5 plus a positive 5, it's going to take me to 0 on my number line. So right away, I know that negative 5y plus 5y equals 0y. And 0 times anything is 0. So we just eliminated the y. So now what we have left is 6x plus 2x equals 21 plus negative 5. So now what I'm going to do is I'm going to combine like terms. So since I have two x's on the left side of my equation, I'm going to add those together and I get 8x. So now I have 8x equals, and 21 plus negative 5 equals 16. So now I have 8x equals 16. And so because I see that that 8 is being multiplied by x on the left side of my equation, I'm going to do the opposite of multiplication and divide both sides of my equation by 8 to get that x all by itself. So I know that 16 divided by 8 is 2. So my x value, or the solution to this system in terms of x, is 2. But remember, what we're looking for in systems of linear equations is a coordinate point to be a solution to this problem, or these two equations. So we're looking for an x and a y. So right now I have just my x. So now that I know that x equals 2 in this system, I can use either one of these two equations, plug that x back into the equation, and solve for y. So I'm going to use the second equation to do that. So the second equation reads 2x plus 5y equals negative 5. So I'm going to multiply my 2 by the 2 that I just determined that x is. So I'm substituting this x for 2. So I've got 2 times 2 plus 5y equals negative 5. And what I'm doing is I'm solving for this y value right here. I'm trying to determine what the y value is that will make, excuse me, both of these equations true. So I want to be able to plug an x value into both of these equations, the same x value and the same y value, that would make both of them true. It would make the first equation equal to 21 and the second equation equal to negative 5. So I'm going to solve this equation simply by multiplying 2 times 2, which is 4. So now I have 4 plus 5y equals negative 5. Now, I'm trying to get y all by itself. So I'm first going to subtract this 4 from both sides of my equation because it's being added on the left side of my equation, and I'm trying to get that 5y all by itself. So negative 5 minus 4 is negative 9. Remember, we go to a bigger negative number when we're subtracting from a negative. So we have 5y equals negative 9. And now that I'm seeing that that 5 is being multiplied by the y, I'm going to do the opposite of multiplication to get that y all by itself. And I'm going to divide both sides of this equation by 5. So I am left with y equals negative 9/5. And negative 9/5 should be the y value that makes both of these equations true. So I can add that y value to my coordinate point, and this is the solution to this equation. And we did that, or I'm sorry, to this system of linear equations, and we did that through elimination. Now, we want to be able to check that our solution is true. So what we're going to do is we're going to graph these equations on a coordinate plane to make sure that we're seeing that the lines are going to cross at the point 2, negative 9/5. So it's important for me to know what negative 9/5 is as a decimal because it helps me understand better when I'm looking at the graph. So I'm just going to write right here for us that negative 9/5 is negative 0.18. So I'm looking for my lines to cross somewhere on the y-axis at negative 1.8, right around or right kind of between negative 1 and negative 2. So that's what I'm looking for. So I'm going to flip ahead to the next slide, and we're going to graph these two equations. So here I have my graph, and I'm just going to write my equations out because it's easier for me if I can see them. So I've got 6x minus 5y equals 21. And then over here in red, I'm going to write 2x plus 5y equals negative 5. Now, remember that point slope intercept form. We want our equations to be in the form y equals mx plus b because this equation tells us two things that are really important for graphing lines. It tells us our slope, so remember that m is our slope, and it also tells us our y-intercept, or that point where our line is going to cross the y-axis. So I'm going to transform both of these equations into slope-intercept form so that I know where these equations are going to cross the y-axis and how many units up and over I need to move to get to my next point. So I have 6x minus 5y equals 21, and so I'm going to subtract 6x from both sides of this equation because I'm really trying to get y all by itself on this side. So I've got negative 6x plus 21 on this side. And now I'm going to divide both sides of this equation by negative 5. And so I now have y equals 6 over 5x, because remember a negative divided by a negative is a positive, minus 21 over 5, because a positive divided by a negative is still a negative. So now I need to plot firstly my y-intercept. So I need to plot that negative 21 over 5. And so I know that it's going to be negative. So it's going to be down here on my y-axis. It's going to be in my negatives. But I don't know what that is as a decimal. So negative 21 divided by 5 is negative 4.2. So this is really negative 4.2. And that's important information for me as I'm trying to graph this. So I'm looking at my, so here's my point 0, 0, which I don't have a point there, so I'm going to erase that. I just wanted to point that out. So I'm going to go down 1, 2, 3, 4. So here's negative 4, and I'm going to plot my point right here, negative 4.2. Now, my slope tells me that I need to go up 6 units from this negative 4.2 and to the right 5 units. So I'm going to add to negative 4.2, 6, and it is 1.8. So I'm going to go to a point about at 1.8 on my y-axis. So that's about right there. But I don't actually want to point there because I need to move to the right 5 units. So 1, 2, 3, 4, 5. Here is my point at 1.8. And then I moved over 5 units. so there's my next point. Now, I don't think I have enough room on this graph. Let me see though, negative 4.2 minus 6 is negative 10.2. So I don't have enough room on this graph. So this is going to be good enough for now. So I'm simply going to combine, and remember I'm really bad at drawing straight lines, so forgive me. I'm gonna draw a line between these 2 points. So there's one of our equations graphed for us. Now, I want to let you guys know that in the problem set, I don't make you graph, but I want to make sure that you understand how to graph these points. So that's why I'm going through this with you guys. All right, so I'm going to subtract over here 2x from both sides of this equation because I'm trying to get it in that form y equals mx plus b. So now I've got 5y equals negative 2x minus 5, and I'm going to divide both sides of my equation by 5. So I've got y equals negative 2/5 x minus 1, because 5 divided by 5 is 1, and it's a negative divided by a positive. So I am going to plot a point along my y-axis at negative 1, because my y-intercept is negative 1. And from there, I'm going to move down 2 units, so 1, 2, and to the right 5 units. 1, 2, 3, 4, 5. Here's my next point. And since I won't be able to move to the right 5 more units, I'm going to go back to my point negative 1, and I'm going to move up 2 units. So 1, 2, and to the left 5 units. 1, 2, 3, 4, 5. So here is my next point. And now I'm going to connect these coordinate points with my really awful line. And I'm going to see where those 2 points are crossing. So notice they're crossing right here at this point. And remember, we said that the solution to our equations, to our system of linear equations, is 2, negative 9/5. And remember that we said that negative 9/5 is equal to negative 1.8. So this is negative 1.8. So we're looking for our lines to cross at about 2 on the x-axis, so about right here. 2 and negative 1.8, so about right here. So remember that when we draw these graphs, or when I draw these graphs, I should say, they're not always exact because our graph doesn't go up by any type of fractions. So they're not always perfectly exact. So I'm content with saying that that point right there is about 2 and negative 9/5. So that's really what I wanted to show you guys there. And I am awful at graphing things, so that's why that did not turn out as well as I hope. It's not that I'm awful at graphing things. I know how to do it. I'm just really bad at drawing straight lines when I don't have a ruler. So I apologize for that. Okay, so now that we've looked at one system of linear equations and using elimination to solve and find the solution to the system, and then we graphed it, let's look at another one. So we've got example number 2 here, and it says solve the following system by elimination. So remember, we're trying to eliminate a variable. So as we are looking at this problem, remember in the last problem, we were able to eliminate y to start with because we had a negative 5y and a positive 5y. So as we're looking at this problem, the first equation has a negative 2x. The second equation has a positive 4x, so we cannot eliminate x. The first equation has a positive 7y and a negative 2y, so we cannot eliminate y. So we have to ask ourselves now, what in the world are we going to do? And there is a solution to this problem. So we're going to still eliminate a variable, but we're going to do it by multiplication. So notice that the second equation has a positive 4x. So we need to turn that negative 2x in the first equation into a negative 4x. So what we're going to do is we're going to multiply the entire first equation by 2. And you're going to see later on in the next couple of examples that sometimes you need to multiply it by a negative number because remember, we're trying to eliminate a variable. So you might have to make that variable negative in order for them to be eliminated. So now we're going to use the property of distribution, and we're going to distribute this 2 to everything inside of our parentheses. So now our equation reads negative 4x plus 14y equals 10. And so now we're going to set these two equations not equal to each other, but we're going to add them together. But instead of using this equation here, I'm going to use my new equation that I just made by multiplying that equation by 2. So now I've got negative 4x plus 14y plus 4x minus 2y equals 14 plus 10. And now I'm going to combine like terms. And so what I know right away is that a negative 4 plus a positive 4 is 0, so I can eliminate the x. So I'm left with 14y minus 2y equals 14 plus 10. So now I'm going to combine like terms. So I have 14y minus 2y, which is 12y. So I've got 12y equals 14 plus 10 is 24, equals 24. So now since that 12 is being multiplied by the y, I'm going to divide both sides of my equation by 12. So I'm going to divide both sides of my equation by 12. So now my y value is equal to 24 divided by 12 is 2. So my y value is equal to 2. So this was really my first step, which was getting it to the point where we could eliminate a variable. So we are now able to eliminate x. Now I've set them equal to each other, or I've added both of the equations together and set them equal to adding both of these solutions together. And now we need to do one last thing. We need to plug this y into one of the two equations above so that we can determine our x value. So I'm going to do number 3 right here, but I'm going to do it in a different color. So now I'm going to use the second equation. So I've got 4x minus 2, and I'm going to plug that 2 in for y that I just found out, equals 14. So I've got 4x minus 4 equals 14, and I'm solving for x. So now that I have a negative 4 on the left side of my equation, I'm going to add 4 to both sides because I'm trying to get rid of that, or I'm trying to get x all by itself. And so I need to add the opposite of negative 4 to get 0 on the left side of my equation. And since I'm adding 4 to the left side, I need to add it to the right side. So 14 plus 4 is 18. So now I have 4x equals 18. And now since that 4 is being multiplied by the x, I'm going to divide both sides of this equation, which we've greatly simplified, by 4. So now I have x equals 18 over 4. But 18 over 4 can be reduced to 9 over 2. So I'm going to write this equation as x equals 9 over 2. Excuse me. So now I have a solution to my system of linear equations. My solution is my x value is 9 over 2, and my y value is just 2. So now I'm really curious, is this the actual solution to this system of linear equations? So now I need to graph these linear equations to make absolutely sure that my solution is 9 halves and 2. So let's graph that right now. So again, unfortunately, I have two equations that are not in the form y equals mx plus b, which is sort of a big bummer. So I'm actually going to move this graph up because I just moved it down a little bit. So there we go. Now we need to turn these two equations into slope-intercept form. So one of my equations was negative 2x plus 7y equals 5. And I'm going to graph the original equation. So I'm going to add 2x to both sides of this equation because I'm trying to get y all by itself on the left side of my equation. So I've got 2x plus 5 on this side. And since that 7 is being multiplied by the y, I'm going to divide both sides of this equation by 7. So I've got y equals 2/7 x plus 5/7. All right. So now I'm going to graph these points. So I'm going to start by graphing my 5/7 because that's going to be my y-intercept. So my first line is going to cross my y-axis at the point 5/7. And so I need to know what 5/7 is, and it's 0.71. So I'm going to put a point right below 1 on my y-axis. So there's my 5/7. And from there, I need to go up 2 units and to the right 7 units. So to this, I'm going to add 2. And so I need to put a point at 2.71. So here's 1, 2, Here's 2.71, but that's not really my point because remember I need to move over 7 units. So 1, 2, 3, 4, 5, 6, 7. So I need a point right here on my graph. So there's my point. Now, from that point, I won't be able to move 7 units to the right because my graph is too small. So I'm going to go back to my original y-intercept point, which was 5/7. And from that, I'm going to subtract 2. So now I'm going to go to negative 1.28 on my y-axis, and I'm going to move to the left 7 units. So 1, 2, 3, 4, 5, 6, 7. So we're right here at that last point. So now I can connect these points on my graph and create a really nice line. So there's my line. That might be the straightest line I've ever made without a ruler. And now we need to see where the other equation is going to cross this line because that's going to be the solution to this system of linear equations. So our second equation was 4x minus 2y equals 14. So I'm going to subtract 4x from both sides of this equation because I'm trying to get y all by itself. So I've got negative 2y equals negative 4x plus 14. And so now I'm going to divide both sides of this equation by negative 2 because I'm trying to get y all by itself. So I've got negative 4 divided by negative 2, which is positive 2x, minus 14 divided by negative 2 is negative 7, so minus 7. So this one is going to be a lot easier to graph. I like when I don't have fractions. It's much easier to graph. So I'm going to plot a point at negative 7 along my y-axis because that's my y-intercept. And that's the point where this graph or this line is going to cross my y-axis. So I've got 1, 2, 3, 4, 5, 6, 7. So here's my point along the y-axis right there. I'm going to erase these last 2 points that I kind of made. And now I'm going to move up 2 units into the right 1 unit because remember this is actually 2 over 1. So I'm going to move up 2 units, 1, 2, to the right 1 unit, up 2, to the right 1 unit. And I'm just going to keep doing that because I'm really trying to see where my graphs are going to cross. And I have this really nice equation that allows me to do that. So 1, 2, over to the left 1. So now I'm going to connect these points, which I'm seeing here, 1, 2 over 1. Okay, I'm going to connect these points. And so we can see that our graph is, or our lines are crossing right at this point right here. Now remember we said that the solution to our equations here is 9 over 2 and 2. So we should be at 2 along the y-axis, and we are. And we should be at 9 over 2 along the x-axis, which is 4.5. So we're at 1, 2, 3, 4.5. So we are just about exactly perfect for that solution to this equation. So we have just concluded from this graph that the solution to this linear system is indeed 9/2 and 2. So we are very happy with that. So now we're going to take a look at another problem. And I think I have just, let's see. I want to make sure that I get through all of these problems with you guys because it's really important that you understand how to solve them because they are all different. So we're going to skip the graphing for the next couple because I want to make sure I have enough time to get through them all. So let's take a look at this problem. It says solve the following system by elimination. So I'm looking at my first equation and I'm trying to decide, can I eliminate x or can I eliminate y? So my first equation is 7x minus 5y equals negative 2. And then my second equation is 3x minus 3y equals 7. Neither one of these equations has the same x value or the opposite x values or the opposite y values. So currently I cannot eliminate either variable. So I need to manipulate these two equations so that I can eliminate a variable. So just the same as when we do that when we're trying to add or subtract fractions, we're going to do it here with these linear systems or with this linear system. So since I have a 7x and a 3x and I have a negative 5y and a negative 3y, I can choose either x or y to eliminate. I'm just going to multiply the equation by the opposite of whatever I'm multiplying the first equation by. So for example, I'm going to choose x. I'm going to try to eliminate x. So remember, I need one of these equations to have a negative number and the other to have a positive number of the exact number, the same number. So I'm going to multiply my first equation by -3 because I want that x to be negative. So I'm going to multiply the first equation by -3 because I would ordinarily have to multiply it by 3, but since I want it to be negative, I'm going to multiply it by -3. So we've got -3 multiplied by 7x minus 5y equals -2. And so we're going to multiply, or we're going to distribute this -3 to everything inside of these parentheses. So I've got now -21x plus 15y equals 6. So that's now my first equation. So that was my first step. Now for my second step, I need to multiply the second equation by +7 because I want the second equation to have a +21. So 7 times 3x minus 3y equals 7. And I'm going to again use that distributive property and multiply everything inside my parentheses by +7. So now I have 21x minus 21y equals 49. So now I'm going to add these two equations together so that I can eliminate that x value. But I'm going to use my new equations. So I've got -21x plus 15y plus 21x minus 21y equals 6 plus 49. So I'm simply adding the two equations together. And I did that because I'm trying to eliminate x. And when I add -21 to +21, it eliminates the x because it's really 0x, and 0 times anything is 0. So we just eliminated that. So now what we have left is 15 minus 21. And 15 minus 21 is -6. So we've got -6y. Whoops. I don't know why it keeps doing that. Okay, so we've got -6y. -6y equals 6 plus 49 is 55. So now I'm going to divide both sides of this equation by -6 because I'm trying to get y all by itself. I want to know what y equals. So y equals 55 over 6, or -55/6. So now what I need to do is I need to figure out what x is, and which means I need to plug this y value back into one of my equations above to solve for x. Because right now I just have a y value, and a solution to a linear system is an x and a y value. So we need to determine that right now. And even though we just manipulated both of these equations, I'm going to plug this y value back into one of my original equations. So I'm going to plug it back into 7x minus 5y, so multiplied by -55/6, equals -2. So I now have 7x plus, because -5 times -55 is a positive, and it's positive 275. So I've got plus 275/6 equals -2. Okay, and so now I have to do the super fun part, and I have to subtract 275/6 from both sides of this equation, and that's really not fun. I completely get that. So we've got -2/1, and we're subtracting 275/6. So I need to multiply the top and bottom of my first fraction by 6. So I've got -12/6 minus 275/6. So -12 minus 275 is -287/6. And I'm going to see if I can reduce this at all. And I can't. So that makes it even more fun. So my equation, I'm going to actually erase this so that I have enough room. My equation now reads 7x equals -287/6. And now I need to divide both sides of this equation by 7, which ultimately means I'm multiplying by 1/7. So I've got -287 over 7 times 6 is 50 or 42, I'm sorry. So we've got, okay, so now we have x equals -287 over 42. And negative 287 over 42 can be reduced to